So hopefully it's coming back to you a little bit as we're going through it. The solving the radical equations is probably the most challenging part of this section. So I want to go through at least one completely with you guys, and this one is a good one, so I'll do this one. And then if you want to stick around, I can probably do one more if you guys want to see one more. So with this equation, dealing with radical equations is if you have the variable stuck underneath the radical, you need to get it out. So you need to think inverse operations. Just like when you have x plus 5 equals 1, to get the x by itself, you subtract 5. So the opposite of adding 5 is subtracting 5, right? So then you get x equals -4. So with radical equations, the inverse of taking the square root is squaring. So to get rid of the radical, we're going to square the right side of the equal sign. So we're going to square the square root. There's an invisible 2 here, remember? But if I square the right side, I have to square the left side too. So I get x squared on the left, and the square root of something squared, they cancel each other out. So this 2, the root, the n, cancels out this other 2, the n. Because we're going to get 20 minus x to the 2 over 2 if we rewrite this with a rational exponent. So this just ends up being 20 minus x to the first power, or just 20 minus x. So that was the whole point of squaring the right side, was to cancel out that square root. So now we have a radical equation to deal with, or sorry, a quadratic equation. And we know how to solve quadratic equations. First, when we have 3 terms here, the x squared, the x, and then the constant term, we want to get all of the terms on one side and everything else on the other. So we're going to subtract 20 and add x to and from both sides. So we get x squared plus x minus 20 equals 0. Factor it if you can. In this case, you can. It factors as x plus 5 times x minus 4. So we set each factor equal to 0 and solve for x. So we get x equals -5 and x equals 4. But the problem is we're not finished. Whenever you get solutions for a radical equation, you always want to check your answers. Check these answers. The problem is that when you square something, remember that you can square 2, 2 squared is 4, but you can also square -2 and get 4. So you want to be careful because this squaring could get rid of something that's negative. And remember that with even root functions, we don't want any negative values inside. So we need to check our answers. So we check, let's first check x equals -5 by plugging each x value into the original function. So before we squared anything, so we want to plug it into x equals square root of 20 minus x. So we have -5 equals the square root of 20 minus -5. Now, without even simplifying this, what's wrong with this equation?
X isn't equal to 0.
X isn't equal to 0. Well, x doesn't have to equal 0.
When you take the square root, you're not going to get a negative.
Exactly. When you take the square root of something, you're never going to get a negative real number. So it doesn't make sense to take the square root of something and say it equals -5. So right off the bat, you can say, well, that's not going to work. But if we go through and simplify, we get that -5 equals the square root of 25. And the square root of 25 is 5. So at the end, we get -5 equals 5, which is not true. And that's what I mean by the problem is when you square both sides, you would get a true statement. But you have to use the original equation. If you get a false statement with your original equation, which we did, that means that -5 is actually not a solution. And then you always want to check both. There are some cases where there is no solution to the equation. So you always want to check both. Don't assume. So there are two things I don't want you to assume. Don't assume that every radical equation is going to have at least one solution. And don't assume that when you get a negative solution that it's not going to work just because it's negative. Okay, so we got -5 and -5 just happened to not work. But we're going to see other equations where the negative x value is actually a solution and the positive version is not. So you always, always want to check and show your work and verify. Show yourself with your own eyes that you get a false or true statement at the very end. So now we're going to check for 20 minus 4 is 16. So we get the square root of 16, and the square root of 16 is 4. So that one does work. So this equation has one solution, and that solution is x equals 4. What questions do you guys have about example 4?